Hello everyone. Today I will be showing you how you can solve exercises for the engineering statics book of Hibbler's 14th edition using the website PermaLearn.xyz, which is a website created by Professor Mengleang and Mr. Usaan from Paragon University of Cambodia. Um, let's dive deep into the exercise. So for today, I've chosen the exercise from chapter 5, which is equilibrium of a rigid body. And here we have exercise 5, R52. Determine the reaction at the support A and B for equilibrium of the beam. So as you can see in the picture, there's one beam or member, and then there's loads, different loads, linearly distributed load, 200 Newton per meter at A, 400 Newton per meter at B. So then we have distance. So from here you have you can go to PermaLearn.xyz. Oh, sorry about that. You can go to PermaLearn.xyz and you can type in your given. So first of all, you look at the member. So the member you have here is 4 plus 3, which is 7 meter. And personally, I like to start at 0, 0. So my x coordinate would be 0, my y would be 0, and the horizontal distance from the begin point is the actual length of the beam or the member. That should be 7. And then now you look at the support. Since there's two support here, a pin and a roller, you can simply add the support here. So at 0, 0 at point A, you have a pin support. So you can find there's 3 different support here. So you can put pin support, and then you can simply add it. Yep. And now you go to B, which is you can see here it's a roller support. So for roller support, you just have to change it to roller, and you make sure you put point B, and now you have it, pin and roller. Now there are other options like hinges, and yeah, since in this exercise in particular there's no hinge, so you can just leave it. And there's also not a joint load since this is linearly distributed. It's no point load too. And now you can look at the linearly distributed load. Yes, so we can simply click on that, and since we only have one member, you just click on member 1. If you have multiple members, it will show up here, and you can add whatever load you want. So this, you have to look at load, like is it horizontal or vertical? As you can see, there's no horizontal load, there's only vertical load. So you just select vertical load, and distance from begin joint from here to here is actually 0 to 4. But yeah, so you put 0 first, and distance from the end joint. Distance from the end joint is actually the distance from this B to this point here, which is 7 minus 4. That's 3. So you can put 3 here. And your begin load is 200 Newton per meter, and this is in kilonewton per meter. So you put 0.2. Oh, negative 0.2 because you take outward positive, and your end load should be 0.22. Oh, negative 0.2, sorry. Negative 0.2. You add it, and it should look like this. And now, since one side of it is 200 Newton per meter and another is 400, you have to split into 2 parts. Now you repeat the process but change some numbers. This is also a vertical load, also number 1, distance from the begin joint. Now the distance from the begin joint is actually from 0 to 4 this time, since you want to start from here. So it's actually 4, and distance from the end joint. So from the end joint to the end joint again, it's actually 0 again. So we don't have to type anything here. And now the begin load. So since we're starting here, our begin load should be 200 Newton 2. So that should be negative 0.2 again. And now for our end load, you have 400 Newton per meter. So that's negative 0.4. Don't forget to put negative. And now you have it. This is our final load. So since we have all the load figured out and nothing else to put here, there's no other forces, no other external forces, no momentum, so you can simply just go to solution. And in solution, you can display multiple, you can only display like one at a time for this for the forces if you want to know the answer for the forces. So for our exercise, they let us determine the reaction at the support A and B. So then we can just click on the reaction forces and display them. So after we display, you can see that there's two forces. One is our reaction force at A, 0.7 kilonewton, and this one is 0.9 kilonewton. And there you go, that's the answer. And if you don't think this is correct, we can always check back into the solution manual. Here, so for NB, they got for NB, they got 957 Newton, which is, you can say, 0.957. And there you have it, 0.957 kilonewton. For the A, reaction at A, there's 743 Newton. And you can check it again by hovering on it. It's 0.742 kilonewton, which is right. And there you go. You have the answer for the exercise 5.2, chapter 5. So thank you to Sir Mengleang and Mengleang for making this website. It makes it easy for a student to solve the 2D exercises. Thank you for watching, and I hope you would use this website to help you with your studies.